My name is Jorge Bonvicini, and I am a 10th grader with pretty bad ankles, so I decided to create an ankle brace. The main problem that I'm trying to solve is that with many braces, they don't help you heal, and that for at least lightweight braces, they have poor durability, support, and comfort. I took it upon myself to create my own brace that is not as clunky, supportive, comfortable, durable, and also helps you with the healing process. To help you heal, I am using heating and cooling. The heat increases the circulation to your ankle and relaxes your injured muscle, while the cooling decreases the circulation, which reduces inflammation and bruising. This is accomplished by using a Peltier electronic heater and cooler, which is a semiconducting device that can both heat and cool depending on the charge. To power and change the charge, I am using a $3 Arduino with a physical relay, allowing me to change the power and the ground to reverse the circuit. The relays are using 12 volts to control the voltage that is going through the Peltier. I am using pulse width modulation, meaning the blinking on and off several times a second to control the amount of heat and cool I get. To adjust it, I adjust the percentage of time on. Those heating and cooling are for controlling the amount of heat and cool your ankle gets, so you can get the maximum benefit of both. To prevent shock from getting the ankle injured even more, I decided to use non-Newtonian fluid. This is a substance that, when under stress, it acts like a solid and solidifies, but during low stress or slow motions, it acts like a fluid. So it's kind of like oobleck. This means that when you need the support, you have the support that you need. But then also when you need a freer range of motion, your motion's not restricted. So when shock is coming towards your ankle, whether it be from walking or whatever, the solid properties come into effect, absorbing the shock. With more shock, the non-Newtonian fluid solidifies even more. But then, when a lot of shock isn't going into your ankle, it acts like a fluid, going to the shape of your ankle, providing constant comfort and support. The non-Newtonian fluid also is great at transferring heat, meaning that it helps get a uniform temperature over all the flesh of the ankle instead of just on one point. My whole brace is wrapped in Ripstop, which is a plastic fabric that is reinforced by being woven into a square-like pattern to reduce ripping and to repel water. The reason I chose to use Ripstop is to make sure that my brace remains durable while also staying lightweight and breathable. Another good purpose that the Ripstop has is to make sure that the foam lining does not fray and get worn down. Speaking about the foam lining, the lightweight design to lessen stress on the ankle so it doesn't get injured more has an issue. You'd be rubbing against plastic, so I decided to add a lining of 3mm neoprene fabric, which is a breathable fabric that adds comfort alongside a soft, squishy, and supportive barrier between your ankle and the plastic frame. This is also one of the solutions I found to an issue I had about support was that I needed a nice, lightweight, but supportive frame. So I came up with this for my first prototype. This top half of this big rectangle and these smaller bits right here are mainly there to add support for all the muscles around your ankle and to give the whole brace some rigidity, as long as in my future prototypes and my future product to be able to house the electronics. Then this triangle right here, which is at the base of the is mainly there for the actual ankle support. So you can't twist your ankle, and so it adds a whole bunch of rigidity for the entire frame. So all this together adds some rigidity for the whole brace to make sure that you don't injure your ankle again while you're wearing our brace. I am planning to put this on the market, and my target audience for this product would be athletes and people that just have bad ankles like me. And I am planning to sell the product, but first I need to improve my design. My plans for the future also include getting this FDA approved. Before that, some improvements that I have planned is to design a new frame that allows a greater range of motion along with more support while remaining lightweight. I also plan on adding a panel that you can interact with to adjust the temperature and the duration of the heating and cooling cycle. After that, I plan on putting this on the market at a reasonable price so it's accessible to everyone.